All right. Well, thanks for the announcement section there. Let's move on to our main presentation. We have some folks, I believe Mark is W9MWR from West Mountain Radio. Is going to talk about DC power distribution batteries and solar.
All right. I'm going to cover a presentation today to talk about DC power. There's a lot of little topics. I'm going to cover a lot of the things that people call in for tech support, have questions about. So it's not a very thorough presentation on any particular thing. Just going to cover a lot of interesting areas. There's a lot of charts and graphs. I'll have a link at the end where you can download the charts if you want to. So let me see if I can share my screen here. All right, this is just an outline of some of the things I'm going to cover. Excuse some of the elementary things. I just want to make sure everybody's on the same page about the problems that we're trying to solve here. If we have a 6-watt light bulb at the end of a 50-foot cable, and that we're going to lose less than 1% of the energy going to that light bulb. We put a 60-watt spotlight at the end of that same cable, and we lose 7%. This is our Ohm's law resistance problem. This is a diagram that shows you from the different size cables what the percentage loss will be. Obviously, the larger the cable, the less loss that you have. So in that previous example, we had a 7% loss with a 12-gauge cable. If we went to an 8-gauge cable, it's only 3% loss. And if we went down to a 22-gauge cable, we're going to get 67% loss. Wow. That's a lot. Where does the energy go? It goes into heat. In a cable, it's not usually too much of a problem as far as the heat goes because it's spread out along the entire length of the cable. Whereas, as we'll talk later on, when you have connectors and switches, it's much more of a problem. The West Mountain Radio website has a calculator on it that you can go to under support calculators that will tell you for a given distance of cable what the loss will be, just like that chart that we just saw. So if you're trying to figure out, like in a vehicle, I've got 10 feet of cable, should I go with 8-gauge cable? Should I go with 10-gauge cable? This is a nice calculator to use to try and figure that out. And here's the connector problem. Let me start on the lower right there with that 6-pin connector. You see that in a lot of the FM radios. What they've done there is by having multiple conductors for each of the poles, they've spread the heat out and they're actually able to do 0.003 ohms effectively is what the resistance is of that connector. At 40 amps, it's going to be about 5 watts. That's getting up there. 5 amps, it's plenty good. Above that, we have the concentric power connector that you have on a lot of your DC consumer electronics. That kind of connector, very poor as far as resistance goes, 0.03 ohms. At 40 amps, 48 watts, it's going to melt quick. Even 5 amps, it's about 1 watt. That's probably the limit of what you can do with that connector. The banana jack in the other corner, that's also not all that great, 0.01 ohms. We still have 16 watts at 40 amps, and that will melt that connector. The power pole connectors are what we're recommending here at West Mountain Radio. They're good at 40 amps, less than 1 watt of heat is going to be in that connector. So that is definitely not going to melt, and you're not going to have a voltage loss at the connector. The 15 amp, 30 amp, and 45 amp contacts are interchangeable. The only difference is the amount of metal that's inside the conductor itself. The different sizes will fit different widths of cable. The power poles are genderless. You can plug any connector into any connector, no male, female thing like you have with a lot of conductors. You crimp them, don't solder them, and they're UV safe. So you can leave them out in the sun. They're not going to deteriorate, but they are not waterproof. Switches, Be very careful with switches if you're using them in a ham radio situation. Most switches aren't anywhere near the amount of current that you're going to need. Look at the DC rating, not the AC rating on the switches. I've got a 100 amp switch there on the right, just so you can see what it looks like. But most of your other switches are not going to have nearly enough current handling for amateur radio use. If you have a problem in your station where you've got a voltage loss, an easy way to find it is to use a voltmeter across every connection. For example, if you've got a half-volt drop, that means you're losing 10 watts in that connection. So dirty contacts, a bad crimp, something like that. It's really easy to find with a voltmeter, just going through your system. I'm going to cover two grounding issues that are really common. This first one shows a base station. It's got a coax cable going up to the antenna, and the guy's also got a weather station on the same mast. The weather station has like a telephone cable coming down to the weather station, and he plugs that into the wall. Here's the issue. If you look at the diagram on the right there, the intended path is from the power supply, is that little green line there. But you've got a second ground path from the power supply. It goes into the wall, through the weather station, up the mast through that telephone pole, and then to the ground on the mast. So that blue line is a secondary ground path. When you key up your radio, half of the current is going to try and go through the blue path, and that's going to vaporize the telephone wire. Second grounding issue I want to just make you aware of. A lot of people have put an amplifier in their trunk. They'll use the ground path to be the vehicle itself, which is a great ground. However, when you use the vehicle ground path, you also have superimposed noise from all of the electronics in the car, the radio, the computer, spark plugs. So all of that noise is going to get superimposed onto that ground path, and that will end up in your radio. I'm going to talk about batteries. Before I get into the specific batteries that we want to talk about, I'm going to show you this Ragone chart. This is what the battery manufacturers just live and die by. They are always looking at this kind of a chart to find out how good the battery is. Basically, what we have is then the vertical axis. It's telling you what the energy is of the battery, sort of like the cold cranking amps, the instantaneous energy you can get out of the battery. And the horizontal graph is showing you how much energy is actually in the battery. And what I want to point out here is the blue line, the darker blue line, sort of next to the purple. That's what a lead acid battery kind of looks like. The yellow line is what a lithium battery looks like. And that green line there is what gasoline looks like. You have to remember the battery people are always comparing themselves to gasoline. Lead acid batteries I'm going to cover first. Always fuse them near the battery. If they get shorted downstream, a screwdriver, something like that, really bad things can happen. Use sealed batteries, not the wet batteries we recommend, just because on the amateur radio use, you're typically near the battery. You want to carry it into your vehicle or whatever, and that acid is just not nice to be dealing with. Don't keep it in an airtight enclosure. The batteries do need to breathe. They get a little bit of vapor out that you don't want to be in an enclosed container. Indoor use, you can use it indoor even though it's got that little bit of discharge, but don't put it in, again, in a sealed closet or something like that. Make sure you dispose of the batteries properly as well. Flooded lead acid battery, just to give you an idea of the technology as we go through the different technologies here. This is the battery I told you probably is not a good idea to use. It's basically got lead plates in there, and then you've got an acid that you pour in over the top to cover the plates. The gel battery is the sealed battery that I'm kind of recommending here today. The difference is instead of having the acid poured in there, they've got these little gel patties of acid that are squeezed in between the plates. The starter battery is the kind of battery that you have for your vehicles. The big difference on the starter batteries, and you can get them in both the gel and the flooded, is that in order to get a lot of cold cranking amps out of that battery, they've added a lot of surface area to the plates. They used to just drill holes in the plates. Now they use kind of a steel roll paste that they put over the plates. The more surface area, the more instantaneous energy you get out. It doesn't actually increase the total energy in the battery, just the instantaneous energy. The problem with that is when a battery is not fully charged, the surface areas on the lead plates will corrode. So a starter battery is great in an automobile where the battery is almost always completely charged. But for ham radio use, if you run that battery halfway down and leave it down for a day or two, the plates are just going to corrode like crazy. This chart here is a depth of discharge chart. This is showing a lead acid battery. If I run that lead acid battery down to 50%, back up again, down to 50%, back up again, this chart's showing I'm going to get, what, maybe 1,200 cycles of life out of that battery. That's just the way what is going to happen. If you run it all the way down to 80%, maybe 600 cycles on the battery. If it's almost always charged, then you're getting over 6,000 cycles on the battery, just to give you an idea here. And I'm going to compare this to some of the other technologies so that you know what we're talking about here. Before I get into that, I'm going to talk about the Absorbent Glass Matt batteries, the AGM batteries. AGM batteries are lighter and a lot of times they're more inexpensive. What they've done is instead of those gel packs, they put these little envelopes over each of the plates, and the envelopes have a fiberglass with acid infused into it. So it ends up with a lighter battery, like, again, a cheaper to make battery. Here's a comparison of the AGM to the standard lead acid battery. The AGM is that orange line on the bottom there. This is on the blue line. If we run down to 50%, we're still at that 1,200 cycles of life. But in the AGM battery, we've got, what, maybe 200 or 300 cycles of life. So the AGM batteries don't like to be discharged and charged back up again. It makes AGM a little bit better suited for like a backup in your home with a base station. You're only going to run it down a few times a year, but not a very good pick if you're going to take it out into the field every weekend. This is a discharge curve. The red line there is how the lead acid battery discharges over its life. And as you can see there, I've got the green line is where the battery manufacturers spec out the battery to. That's what the number is that's stamped on the back of the battery, 10.5 volts. The blue line I put in there is the line 11.7 volts, which is the minimum voltage that most of your radios are going to want for transmit. So effectively, if you're interested in transmitting, you're only going to have 66% of the life out of that battery before you hit that 11.7 volts. And if you have some additional losses in the station, cable losses and stuff, that brings it down to like 39% on the yellow line up there. So this is just a discharge curve on a typical lead acid battery. This is just a typical car size battery that we're looking at here. This is that same chart, but this time what I did is I simulated transmit receive. I transmit for 30 seconds, receive for 30 seconds, go back and forth like that. Now you can see every time you transmit, the voltage drops down. So that makes this chart a lot worse. That 11.7 volt line is now at 35%. So you're only getting a third of the energy out of your battery. That's what's stamped on the battery. This is just something you have to be aware of when you buy the batteries and you realize how long you tend to use them and what the battery is rated for. Lithium batteries. Ever since lithium batteries came out, you've probably heard the stories about the cell phones getting too hot. You had to throw them in the garbage can, things starting on fire. This is the state of the art. They say about 1 out of every 100,000 lithium batteries is going to have a thermal event. What happens after that thermal event depends on the manufacturing, what the material is on the battery. They say for automobiles, it's about 1 out of 1,000 that has a problem. For cell phones, it's about 1 out of 200,000. The manufacturers of the batteries will want you to know that when the gasoline automobile came out, everybody was saying that was too dangerous to put people into it because the gasoline was too dangerous. And they will also point out that even today, 1 out of every 1,300 automobiles start on fire. The gasoline tank starts on fire. So anyway, that's the that's the spin on the lithium batteries. But let's talk about some of the benefits. First of all, there's a ton of chemistries. And there seems to be a new chemistry that comes out every year. For amateur radio use, the best chemistry is the iron phosphate, the LiFePO4 there at the top line. It's a little safer. When I say safer, that means if you pound a nail into it, it's not going to explode like most of the other technologies will. It's got a real high life, and it's good for high loads. So this is a really good battery for amateur radio use. And all of these charts that I'm going to run through, these are all the iron phosphate kind of charts. I've got my same blue and orange line there for the lead acid batteries. And this is the green line is for the lithium ion battery. Let's go to that 50% mark again. We run the battery down to 50%, back up again. We're going to get 6,000 cycles out of that battery. So that's something you definitely have to keep in mind when you're looking at the prices of the batteries. Temperature, the green line represents the lead acid battery. The lead acid battery puts out more energy as the temperature gets higher, puts out less energy as the temperature gets lower. The lithium battery, however, has a limit of about 32 degrees that you can charge it at. You cannot charge a lithium battery below freezing. It also begins to degrade very quickly after about 80 degrees F. So it's got a sweet spot as to where you want to operate that battery. This is a discharge curve, the same curve I had before for the lithium ion battery. One thing that you'll notice is it doesn't drop nearly as fast as that lead acid battery dropped. In fact, I'm getting at that 11.7 volt line, I'm getting 92% of the energy out of the battery that's stamped on the side of the battery. You can see that until you get to the end, it really doesn't start dropping off. So this behaves a lot better than your lead acid battery. I want to talk just a little bit about charging, just so that you understand what's going on in the charging world. A lead acid charger, what you do is you pump voltage into it until you get to a certain current, and then you wait for the voltage on the battery to rise. That's that first section of the graph there. Once the voltage gets up to a certain point, you hold the voltage there, and the current draw from the battery will start to drop. Once it drops to a certain amount, you go into a float stage. You keep that voltage on the battery. This comes back to that corrosion thing. Whenever possible, you want to keep voltage going into that battery to prevent the corrosion. So you trickle charge a lead acid battery and keep it fully charged up. The lithium ion battery has the same first two stages. However, once you get to a certain point where the battery stops, or at least is only a little bit drawing current, you need to stop the charging altogether. The lithium ion battery is the opposite of the lead acid battery with that respect. It doesn't want any additional energy in it. If you do put additional energy into it, it'll overheat. So the moral of that story is don't use a lead acid battery charger on a lithium ion battery, unless there's electronics in the battery that are designed to get around that. Cost comparison here. The middle line there is showing a 10 watt FM transmission, talking 50% of the time. It shows there that the dollars per amp hour, the lithium ion battery is quite a bit more expensive than the lead acid battery. But if you're doing 100 watts of transmission and you're talking 90% of the time, 50% of the time, the cost is getting very close, very similar. So you have some of the additional advantages of the lithium ion battery to take into account. We've got a calculator online at West Mountain Radio as well for determining how long a specific battery is going to last in a particular usage. I've circled on there if you're doing CW, that's the green line. And if you talk 70% of the time, it shows a 74 amp hour lead acid battery will last about the 6 hours that I've got there. So you can compare the different batteries and different technologies to figure out what's best for you using that little chart on the West Mountain Radio website. Battery weight, amps per pounds, lithium ion is way ahead, 6 amps per pound compared to a little over 1 amp per pound for the lead acid batteries. Talk a little bit about battery boosting. You remember the the chart we had before, in the upper left corner there, how the lead acid battery drops, at a pretty steep rate. If you use a battery booster, you can get the additional energy out of the battery. It boosts the voltage up so that you have more than the 11.7 volts that the battery, that the radio wants, and use more of 100% capacity out of that battery. West Mountain Radio just started selling a battery booster. It was made by a, let me just see here. It was made by used to be manufactured by Tim. It was designed by Dan. They were selling it for many years. Tim passed away, and Dan licensed the design to West Mountain Radio. So we've taken over the manufacturing of it just recently. And let me go back to that previous slide here. 74 amp hour battery, typically it costs you around $300, and you get 10 hours of transmit time out of it. Lithium battery, $360 will get you the same 10 hours, but it'll be a 40 amp hour battery. If you take the lead acid battery, 74 amp hours, with the battery booster, you're going to get 15 hours of talk time out of it, and the price is going to be around $550 the first time. But then as you keep buying batteries, it's just going to be $300 from that point on. The equivalent would be a 60 amp hour lithium battery, which is around $570 to get the same 15 hours. Talk a little bit about battery testing. The two big things that cause the batteries to die. Now, let me just go down to this chart here. The two things are corrosion, which we talked about earlier, and dry out. Dry out is every time those batteries vent, they vent some acid, and that acid is never recovered. Eventually, there's not enough acid for the battery to work properly. And back up to this chart here. 2 to 10 years on a lead acid battery, depending on how it's used. 64% of the lead acid batteries are dead by the age of 7. So 5 years, probably a good number. 77F, more like 3 years at 90 degrees F. When the battery drops about 20% in capacity, if it's stamped as an 80 amp hour battery, it goes down to 60 something. Then you've exhausted about 85% of the battery life, and it's going to start dropping much more quickly after that point. So for the corrosion issue, we talked about the cause of that. It's basically when the battery's not charged, the plates start to corrode. Dry out, when you charge it or discharge it, that they vent gas. Two test methods I want to talk about. When you go into the automobile shop and they test your battery, they do a fast test. They put the battery under heavy load, and they look at how fast the battery drops in voltage with that load. That covers about 60% of the batteries, so you can sort of tell what's going on there. The other option is to just let the battery drain down and figure out how much energy was in the battery. This gives you a much more accurate, I've got some better charts here, much more accurate way of producing it. So with the voltage under load, you can detect the corrosion 100% of the time, and it can predict that it's going to fail about 95% of the time. For dry out, very hard to detect when you just put the battery under load. 15% of the batteries will fail that way when you put it under load, and it won't predict dry out at all. The true capacity test, where you actually measure the amount of energy in the battery, that detects a bad battery 100% of the time for both types, and it also predicts a failure of a battery about 95% of the time. This is the West Mountain Radio battery tester. It's the true capacity test. It basically drains the battery. It's an electronic load. And by the way, this has a lot of uses beyond just battery testing as an electronic load. You want to put 20 amps on something, draw down a battery, test the power supply under load, stuff like that. It's really a fun toy to play with. Basically, you just put in all your test parameters, what you want it to do. You saw some of the charts I had earlier. Those charts were all created from the CBA battery analyzer. You can do multiple tests on the same screen. You do a test every 6 months on your battery. You can actually track it over time and see what's going on, kind of get an indication as to where you might have trouble. The duty cycle testing, the chart that you saw earlier, another feature that we have in the battery tester. We've got a whole bunch of them. The one in the upper left corner there is our most common one. It can do about 150 watt discharge. But we've got 500 watts, 1,000 watt, 2,000 watt systems. And we've even gotten bigger than that. We just sold a 4,000 watt system this week. And then we've got a small one, that little 10 watt unit there, that's more for coin cells batteries. One more thing I want to talk about on the battery testers that's kind of cool. We have a voltmeter, West Mountain Radio does, called PowerCheck, which is a volt amp meter that you can use for checking things out in your station. But one of the nice features of that is there's an internal log. You can actually log a voltage profile, a charge, discharge, whatever. And we have a way of playing that log back into a file and then loading it into our battery analyzer. You can put that exact same load onto the battery as what you experienced in real life. So if you had a drone, for example, you could record exactly what the current draw was, you know, for takeoff, flight, landing, that kind of a thing. And then you can play that same thing back for various brands of batteries to find out what batteries work the best for you in a particular situation, or try and create a particular problem. Uninterruptible power supplies. This is the PowerGate that West Mountain Radio has been making for years, the Super PowerGate. Extremely popular product. A lot of people have it. Basically, it's got two diodes in there so that it can take power to the radio from either the power supply or the battery. When you lose power from one or the other, the radio just keeps running. You don't even notice a blip. And then it's got a battery charger in there as well. So when you do have the AC power, you can keep the battery charged. So this is the kind of thing that works well in a lot of different situations. And again, it's a very popular product. A few questions that people frequently ask. Putting batteries in parallel. It works out okay as long as the batteries are the same age and the same type of battery. What you don't want is a situation where one battery ends up charging the other battery. So if a battery starts to go bad, then you're going to run into a situation where the one good battery is spending its whole lifetime charging the bad battery. So if you do this kind of a situation, after a couple of years, you may want to periodically break one of those connections and just put a current meter in there. Make sure you don't have a lot of current flowing from one battery to the other. Solar power, also a very popular topic these days. I've just got some examples here of how big the various panels are, the sizes of the panels. If you go onto Amazon, about $1 a watt seems to be what you're seeing for solar panels. It changes a lot every couple of months, so keep an eye on it. With cases and stands and fancy stuff, you can get up to $2 a watt on those panels. This is a chart that we use the same battery analyzer to analyze a solar panel. And it has a feature in it where it can sweep the panel and draw a different amount of current on the horizontal graph there. And it tells you how many watts of power it got out of the panel based on how much current was being drawn. As you can see here, solar panels have a sweet spot. This particular panel looks like it likes 4.4 amps. We're actually able to get over 65 watts out of the panel. If you draw less amps, you can see you're getting less watts out. So it has this little sweet spot in there. This is the same chart. I superimposed a second chart on top of here. If you look in the lower left corner, you see this little blip. That little blip is when I pointed the solar panel to the sky, which does not have the sun in it. So this is the difference between sun directly hitting the panel and indirect sun from the other sky. That's an important thing to note because the sun moves. So if you're planning on doing something solar-wise, try and get as much sunlight as you can. This is our PG40 that we were talking about earlier. A lot of people want to use the solar panels to charge the batteries. You can connect battery chargers in parallel in general. So even though the PowerGate has a charger in it, you can put a solar panel charger in parallel with that, and the two will work out together okay. The charge controllers that you use for solar panels are called MPPT controllers. What they do is they find that sweet spot that we were looking at earlier on the graph, and then they'll draw that amount of current from the panel so that they can get the maximum amount of energy going into the battery. This is the newest PowerGate product from West Mountain Radio. We call it the Epic PowerGate. That actually has an MPPT controller built into it, so you can directly connect it to a solar panel without a charge controller. And it's got the same switching between battery and power supply. It's got the same charging on the battery. The other big difference in this one is we allow for lithium battery charging as well as lead acid battery charging. And instead of diodes, even though I've got diodes shown there, we're using FETs. So it's a very low voltage drop between the battery and your radio, about a 0.05 volt drop, as opposed to about a third of a volt that you get on the PG40S. That is my presentation. Are there questions?
So Mark, maybe I'll start out. It's Leon here. I have a big lead acid battery in my shack, and I use it for backup with your using your equipment as you've described. But I haven't tested that battery for a while. Is it a good idea to pull it off the shelf and use a CBA to discharge it and see what its capacity is? And it's a big battery. I can't remember now. It's kind of like one of those 60 amp hour batteries like you were talking about earlier. Can you just run it for multiple hours and run it down to a certain voltage? Is that a good way to test it?
Well, the one thing that you want to do is you don't want to drop the voltage below 10.5 volts.
Yeah.
So that's something that the CBA is good at. You can tell it to put on a load, 10 amp or something like that until the voltage gets down to 10.5. So that's a nice way of doing it. If you've got a way of watching the battery, you could like put a headlight on it or something like that and just watch it and see how long it takes to get down. Although that could be like 10 hours or something.
Okay.
But yeah, just make sure you don't go below the 10.5 volts. It probably is important to test it periodically if you're using it for something that you care about. Definitely if it's a sump pump battery or something like that, you want to not put it in your basement and forget about it.
Yeah.
And if you're going out into the field and you're going to use the battery and you want to make sure it's good, yeah, not a bad idea to test it. Again, once the battery drops below 85%, I would just get a new battery.
Okay.
Hey, Mark, is there a big difference in efficiency of the lead acid versus the other technology that you were talking about in terms of the amount of power that you put in versus the amount of power that you can actually get out?
It's not as much of a difference as you would think. So what you're saying is the charging energy. There's not that much of a difference. The biggest difference that you find is the lead acid batteries, you end up trickle charging it basically forever because you want to keep that battery charged. Most of the energy that you lose is in the trickle charging because you may be trickle charging it for weeks, even though you're not using the battery. So that's the biggest loss. The lithium batteries have a little bit less self-discharge, so they'll hold the charge longer. But as far as the energy going into the battery, it's about the same. It's somewhere in the neighborhood of a 10% loss for both batteries.
All right, thank you.
So I'm just curious. I own a whole bunch of your products. They're great. They've been fantastic. Had a little issue, and you guys were very good about getting it replaced. So thank you for all that. I'm curious. Are there any ham radio related power management products in the pipeline that might excite us?
Not a lot. We've had a real trouble in the last 6 months. With supply and stuff like that. So a lot of things that we were planning on doing got put on hold. And right now we're just trying to keep our head above the water, getting stuff manufactured. It's really tough buying parts right now. The things that we're looking at, we're adding more rig runners that have a horizontal to them. We just came out with the Epic PowerGate that's got the horizontal mounting, because people want different things. So there's not anything big DC power wise. We are coming out with we just came out with a new rig blaster for those who did digital mode stuff, but not much in DC power.
Very good. Thank you.
You do with regard to like solar, are you doing anything with inverters in addition to the chargers that you have?
We have not. We have people that periodically ask us about that because they've got AC needs as well. We've been afraid of inverters because of the RF noise.
Yes.
And doing one that's going to be suitable for amateur radio use is going to be a tough deal. We went through that when we came out with the Epic, because it's got that MPPT controller in it, which has got the same problem. And we went through a lot of work to make that noise-free RF-wise. But a regular inverter, that's going to be a tough sell.
Well, that's kind of exactly why I was asking. When you research the inverters out there, it's a big issue. So somebody who's got an amateur radio mindset would be welcome to that market, I think.
Yeah, people ask about it. We keep our eye on it, but it's a little scary.
Mark, could you say a little bit more about the, I forget the exact name of the device now, but it was the device that seemed to stabilize the voltage of the battery over time. So it was a flatter, it was basically a horizontal curve, so to speak, with a sudden decrease in the power. Could you say a little bit more about why we might want to use one of those devices in our stations with our batteries? Does it, again, could you explain again, does it increase battery life? I gather, you would have a more stable voltage over time before the battery just quits. But could you say a little bit more about the utility of that device and why we might want to use something like that?
If you remember one of the earlier charts, I showed you that if you're doing receive transmit on a car-sized battery, you're really only going to be able to use a third of the energy in that battery before the voltage hits that 11.7 volt limit that your radio wants.
Yeah.
So you're paying for a 74 amp hour battery or an 80 amp hour battery, but you're not getting that many amp hours out. You're getting a third of the amp hours out. So if you want to fully utilize the battery, what you need to do is boost the voltage up to something that you can utilize. And then you can run that battery all the way down to the 10.5 volts that the manufacturer allows you to run it down to, and get the full 100% energy out of that battery.
So how does that work? It seems like it almost feels like you're getting something for nothing. So how does that actually work? Is that because the actual voltage that you see at the output is maintained at a level, but you don't end up discharging the battery to?
It's actually a pretty clever design. What Dan did in his design, and he actually published an article in QST many years ago on this whole technique. What he does is he takes the voltage that you have. Let's say you have 11 volts.
Yeah.
Then he runs it through a switching regulator, and he's got an isolated power supply output from the switching regulator. So he's going to create maybe 2 extra volts. And then he sums it at the end and adds in the 2 volts to the 11 volts that you have to end up with 13 volts or whatever voltage you want. So he's got a switching regulator, but he's not switching the entire voltage. He's just switching enough to get some additional volts, goes through an isolated power supply, and then he's able to add it in to the total voltage. It's a very clever design. It reduces the noise that's being generated from the switching regulator by doing it that way. And he's able to take the battery all the way down to the 10.5 volts and still get your full 40 amps out. And by the way, I may not have mentioned it, but the unit that we sell is rated at 40 amps, but you can connect these in parallel. So you can get 80 amps, 120 amps, whatever you need.
Okay, thank you.
How does that compare to these like buck boosters that you read about that do a switching supply like that as well? I mean, you mentioned about knocking the noise down. I know a lot of those, particularly the Chinese ones, are really noisy.
Yeah, we have a competitor that has a similar booster product, and we've looked at the noise on it. We're way quieter than that is. And when you look at the booster, it's a pretty nice size But if you open that thing up, it's almost all capacitors. I mean, you know, space-wise. So he's got a lot of capacitors stuffed in there, and it really does a good job noise-wise.
I noticed that some of the devices that you were offering, battery testers, battery chargers, that sort of thing, were connected to a laptop computer. And I was wondering whether you're stuck with Windows as the operating system, or whether you can run a Linux or some other open system to run the software necessary. Thank you.
The battery analyzer software is all Windows-based. However, we do have people running it on Macs and stuff under a Windows emulator. So we'll run under a Windows emulator, but the software that we've got, we've all developed for just Windows. I should point out, if you're a developer, you can directly control the CBA itself. We have a software development kit to tell you what commands to pump into it and stuff. So it's probably too much for just a hobbyist to deal with. But if you had a manufacturing environment where you wanted to test batteries on an assembly line or something like that, we do have a software development kit where you can just send commands directly to the units on your own.
Okay, that sounds like an interesting possibility, even though I wouldn't be doing that much, but programming is one of my hobbies too. Thanks much.
Okay.
I have a question about lead-acid batteries. I was given to understand that if you totally discharge a lead-acid battery, it doesn't like that. It pretty much does it in. Is that true for all types of lead-acid batteries?
Yes, at least that's what the manufacturers will say. Now, we have run some batteries all the way down here and been able to get them back to life. One of the challenges is a lot of chargers won't attempt to charge it if it's completely drained down. What you might want to do is put it on a trickle charger for a little while to bring the voltage up, and then use your bulk charger. So we've seen batteries survive it, although it's probably reduced the life of the battery substantially. Remember, when the batteries run down, the lead acid plates start to corrode.
Thanks. That's what I thought. I was afraid of this. So even the sealed lead acid batteries, if I do something stupid and run it all the way down, I'm probably going to hurt it.
Yes, the exact same problem you have with the flooded batteries. All of the lead acid batteries have the same problem.
But lithium ion, you can take all the way to the bottom and bring them back.
Yes, you can. They don't suffer the same kind of a problem when they're left discharged. In fact, if you're shipping them, they tell you to drain it down to like 30% to ship them, so they've got less energy in case something happens. A lot of times the distributors will keep them on the shelf at 30%. So yeah, so they do something when you give them to the customer, but you really have to charge them up first.
I haven't started using any. I have a few of the power distribution, but I don't have any solar panels and batteries. I'm looking to get started up, trying to do a little bit of that for a mobile trail-friendly setup, you might say. So, I mean, in your advice, what would you think would be a good way to kind of get started with that?
Well, of course, our Epic PowerGate is the best option. Connected directly to the solar panel, and you don't have to worry about the RF noise. If you've already got one of our older PowerGates, get a charge controller for your panel, but you probably have to disconnect it while you're on the air, because the commercial charge controllers do generate a lot of noise. But a lot of people are getting panels that are in the 100 to 150 watt size. That seems to be about the right size for amateur radio.
So those, you want to transmit when you're actually on battery, though, rather than running off of the panels itself.
Yeah, you're not going to get that much current out of the panels.
Yeah.
You know, for a smaller radio, yeah, but you're not going to do 100 watt transmissions or anything like that on a solar panel.
Coming back to just another question about the solar panels, because it's something that I've been thinking about as well. So for like a home installation, if you want to set up a panel to keep a let's say, keep a backup battery charged and so forth. Again, is one of these 150 watt panels the best way to go? And then, you know, your graph was interesting where you showed the difference between direct sunlight and I guess it was very indirect sunlight. How do you position a panel, let's say, for use at home to, because the sun, like you said, is moving all day, and if you're going to keep the panel directly pointed at the sun, you got to have something to move it, which adds a whole nother layer of complexity. So how would you recommend, how big and how would you recommend setting up solar panels for that kind of use?
Well, like I say, 150 watt is a good size. And it seems like what people are doing is pointing it just directly to the southern sky in such a way that it's going to get the most sun throughout the day, assuming you're not going to move it throughout the day.
Yeah.
So you're not going to get as much sunlight as, you know, your plants do, but throughout, you know, many hours of the center of the day, it's going to be pointed pretty much at where the sun is.
And does it matter, you know, again, we got a lot of trees around the house. Does it matter if shadows move across, the shadows from the tree branches and the limbs and stuff move across the panel, or can you just live with that and, you know, take what you can get throughout the day as the sun moves across the sky?
It's going to depend a little bit on your needs. I will tell you this, that kind of a thing caused us some headaches when we were designing the Epic, you know, because the power goes away. We say, oh, you disconnected this panel. And then suddenly it comes back. And then we're saying, well, the battery isn't really ready for charging yet, but you sort of have to remember, well, I was in the middle of charging and I didn't really get it fully charged up and stuff like that. So yeah, we did a lot of firmware diddling to get to deal with that kind of a thing. It's not just tree branches, clouds can make that thing appear like it just disappeared and then come back again a minute later.
Yeah. So if you use something like the Epic charger, that really helps to kind of, so to speak, smooth things out and manage the charging of the battery because of the firmware that's written into the system.
One of the interesting things here at West Mountain Radio, we sold a lot of those Epics, and all of our customers seem to be tinkerers. So they notice these things, and they'll send us information. Say, hey, look what happened here. Look what happened here. So so we keep diddling with the firmware and getting it to cover all of the different situations.
Cool. And then, so to get the latest firmware, is the firmware? I haven't looked. I've got an Epic. Can we download and update the firmware in these?
Yep, it's right up on our website. You can download the firmware. There'll be instructions for how to put it in.
I've got a bunch of dead lead acid batteries from UPSs. I keep them around because they're handy as counterweights and things. Are any risk to that? Like, are they, these are of course sealed devices. Any risk they'll suddenly burst open and get acid all over my books or whatever?
Not unless you drop them. And if you're ready to get rid of them too, Batteries Plus should take them.
A quick question. What is the PowerGate probably the best thing to use if you have like a solar panel and you want to hook it up with a little battery? And does that do the charge regulation for you too?
Yeah, it takes care of the charge controller part of it. And that's one of the big features. If you're going to use solar panel, you just, you know, buy your charge controller on Amazon or something. It's going to be noisy. It's not going to be suitable for radio use. So one of the things we did in the design of the Epic was to put a charge controller in there that's radio friendly. So yeah, that's probably your best situation.
I have one I built from the ARL handbook that was in there about, I don't know, 5 or 6 years ago.
I'm not familiar with that one, so I can't say.
Can Epic work with lithium batteries in buffering configuration? That means charging the battery like 99% of the time.
Yeah, many customers do just that. You do need to set the jumper inside the Epic to tell it that it's lithium. That way it knows it doesn't trickle charge. When the battery gets down to a certain voltage, you know, it's 12 point something volts, it'll start a charge cycle. It'll charge it all the way up, but it won't continuously charge it to damage the battery.
And what lithium chemistries do you support?
It'll work with all of the lithium batteries. You may have to adjust the charge voltage a little bit depending on the chemistry. But again, we're strongly recommending the iron phosphate chemistries.
So the PowerGate, you said you have you can upload new firmware into. Are there any pieces of firmware that are configurable? So if you have something slightly different, then you could actually modify a few settings to establish slightly different behavior in the firmware for the PowerGate?
You know, we've got a settings menu in the software. I didn't mention it. There's a USB port on the Epic, so you can connect it up to a laptop, and just using a terminal program, you can see what's going on. It'll actually print out all the voltages, the current draws, what's going on in the unit, what it thinks about the charge. But then there's a settings menu that you can bring up and set all of the various parameters. What's the charge voltage? What's the trickle charge voltage? Do you want it to trickle charge? So on and so forth. So all of that stuff you can set in the firmware. If you're not into using the USB port, there are some jumpers you can just set inside to use our default settings.
So that USB port in the settings, that's within like a serial connection. So
Yeah. Once you connect it up to the laptop, it appears like a serial port. It'll be like, you know, COM7 or something like that on your PC. Yeah. And we've got some software that'll just talk to it. Otherwise, you could just use your favorite terminal program.
Oh, that's pretty nifty. That, to go back to the question about, you know, Linux and so forth, having a terminal program sounds like you can actually just work on it on any OS if you're using a terminal application. So that's pretty cool.
Oh yeah, Linux or whatever.
One more question. Your website says that the DC power devices are on pre-order. What does it mean?
If it says pre-order, that means we don't have stock at the moment, but we'll take your orders. We're running in a situation right now where almost everybody who's getting stuff is getting it because they went on pre-order. We've got like a 200 of a product that's coming in next week. We've already sold them all. So getting on a list is the best way to get it. If you change your mind, it's easy to get off the list. Just call and say, I've changed my mind. We don't charge your credit card until we ship. It's just been really tough for us to get parts right now.
Just out of curiosity, which parts are probably in short supply the most? Capacitors or what?
We're having problems like with the metal enclosures. The things that are, you know, we usually just go down the road and somebody does for us. There's a lot of labor problems where people are just not coming to work, and it's cardboard boxes are a problem. The metal enclosures are a problem. The plastic boxes are a problem.
Wow.
It's just tough. Some of the parts we're able to get overseas, just the regular capacitors and stuff like that. But yeah, it's these custom parts that are just killing us because all of our enclosures are these custom metal enclosures and they're powder coated and stuff like that. And we've just been relying on the fact that we can just, you know, like I say, go down the road and have people build this stuff up for us.
They have trouble. We're having trouble with SMA connectors, RF connectors, because they're being manufactured in France, and they're saying no, we can't make them. We're shut down.
Yeah, and then and the shipping companies too. They're running, you know, slow speed right now. FedEx, UPS, they won't guarantee any kind of delivery times.
Have you considered selling bare boards without enclosure for integration in own DIY power solutions?
No, but one of the products we just started doing that with, we have a clear speaker product that has a DSP filtering, and we just started selling just the DSP board all by itself for people who want to build that into their own speakers. So we're going to keep an eye on how popular that is. We've talked about doing kits and stuff too, you know, just, you know, because some people like to tinker and build their own things. So we're kind of keeping an eye on how popular that kind of a thing is. But I hadn't thought about it in the DC power side of things, yeah.
And would you consider doing it on per request basis?
Oh yeah, absolutely. Because we have the parts here, we have the boards here. Yeah, contact our salespeople. Say, hey, I just want a circuit board. I don't need the enclosure. You may actually get it faster than the people who are waiting for the enclosures. They know they have prices and stuff like that anyway. Because we have, you know, guys who, you know, the station got hit by lightning. You know, well, we're just going to sell you a whole new printed circuit board. You can keep the case. You know, that kind of a thing. So yeah, they know what the price is.
Well, I guess if everybody's kind of quiet here, I just want to say thank you very much, Mark, from the Vienna Wireless Society. It's been a pleasure. Excellent presentation to enjoy on a Friday evening. So thank you very much for spending your Friday with us and talking about this stuff and entertaining all our questions.
Well, thanks for inviting me.
Well, I guess if everybody's kind of quiet here, I just want to say thank you very much, Mark, from the Vienna Wireless Society. It's been a pleasure. Excellent presentation to enjoy on a Friday evening. So thank you very much for spending your Friday with us and talking about this stuff and entertaining all our questions.
Well, thanks for inviting me.